Hello there everyone, my name is Crazy Caleb and welcome to Simon Shines. So this is the way the module looks, and what we have here is we have a little light bulb that is present on this module that is quite stretched out, mind you. We also have a little light switch that's going to be represented with when we're going to turn this light bulb on and off, and we're going to get a series of different colors from this light bulb here. So let's get right into this module. So the first things first, this module itself is fairly simple to do, and it's not that hard to do. It's just the problem is that you don't know how long you have to do this for. There's a series of different stages, which you're going to have to go through, because you're going to have to repeat steps 2 and 3 until the module is solved. So let's get right into this. So first things first, we need to calculate an initial time, and we need to actually figure out what we're going to be looking at here with regards to when we're going to flip the switch to get the series of colors that we're going to get from the light bulb here. And one important thing to note down early on is the fact that the light can never be on for longer than 2 bomb seconds. So keep that in mind. And obviously doing this with strikes is going to be very, very difficult. And my biggest complaint about this module, and my biggest pet peeve with it, is going to be how big this highlight is for the switch. It is not able to be accessed anywhere else, and especially if you have to do this on, say, for example, far away cases, on bigger bombs especially, this little highlight might be really annoying to get to, and it's not going to be that great. It's not going to be great of an experience. So let's get right into this. So first things first, we're going to need to take the sum of the digits in the serial number, and we're going to multiply this by 2, and then we're going to take the digital root of this number to get our initial time. And this is going to be essentially the first one that we're going to build off of this. So let's get right into this. So one of the things that we're going to take a look at is this. So we have 1, 3, 5, and 2. Let's pop out our handy dandy calculator here, and let's see what we have here. So we got 1 plus 3 plus 5 plus 2. Now we're going to multiply this by 2, which is going to give us 22. Then we're going to take the digital root of this number. For those of you who are not familiar with how digital root works, the digital root is a continuous summing is the continuous summing of a number until one digit remains. So in this example here, what we're going to essentially do is we're going to do 2 plus 2, and this will give us the result of 4, and that's going to be the digital root of our number. Now, what's going to happen here is with this module, what we're going to do is we're going to flip the switch when the last digit of the timer is going to be a 4. So let's do that. And we're going to do this real quick here. So we got green, yellow popping up. That's what we're going to do. Green, yellow. So we're going to note that down, green, yellow. And now what we need to do is we need to observe the flashing colors and calculate a new time. Now, one thing that's very important is the order of operations is always going to be in red, green, blue, and yellow order. Essentially the way that it is listed here. You will go from top to bottom, and if these colors were present, that means that you are going to note these stuff down. So, green and then yellow is what we're going to do here. And this actually allows me to elaborate what these special rules are. Now, one thing that's very important is that we have edge work cases here. Note that this slash does not count as division, but rather it is comparing two values of edge work conditions, and what it wants you to do is in case of edge work slash edge work, we need to take the greater of the two. So, it's going to be the digit plus whatever case we're going to get here, and then we're going to take the digital root of that. So let's take a look at this. So the first one that we have is green, and we need to take a look at the indicators and battery count. So we have 3 indicators and we have 0 batteries. Note that if you happen to do division of 3/0, this does not make sense. This is dividing by 0 is undefined, so this is why this is not a division case. And what it wants us to do is it wants us to take a digit that we previously had, in this case 4, and now what we're going to do is we're going to add the greater of these two edge work conditions. So in this case, it's going to be 3. So now we're going to add 4 plus 3, and this is going to give us a 7. This is already one single digit, so we don't have to worry about doing the digital root here. Okay, now for yellow, we're going to do the exact same thing. Digit plus the battery holder or port plate count. Let's see which one is greater. Now both of these actually happen to be 0, so we're not going to have to worry about this. So the digital root of this is going to be 7. And now what we're going to do is we're going to essentially get a new time, and we're going to get some new colors here. So we are going to do this on 7. I just missed it. That's fine though. Let's do this on 7. And then what we have here is green and red. Okay. Note that it did start off with green, but the order that we're going to do this is red-green because we're going to be following the red, green, blue, and yellow. Make sure that's very important. And in case of a strike, the module does reset back to the beginning. It's not fun to do, trust me. It is not that great it's not that great that it resets you back to the beginning rather than just keeping you on the exact same stage. So bear that in mind. So let's get right into this again. So now we're going to be building off this 7 once again. And now we're going to be doing red and green. So red is going to be the digital root of the digit times 2. So we're going to multiply 7 times this by 2. That's going to be 14. We're going to digital root this. 1 plus 4 is going to be a 5. Okay? Now, the digital root of the digit plus the indicators or battery count, we determined that it was indicators last time, so it's going to be adding 3 to this. Okay, and now we're going to hit the switch when it is 8 again, because we don't have to do digital root. Okay, blue, yellow. Blue, yellow is our next color. Good, I'm able to show off all these colors here. Alright, so blue and yellow is going to be the order that we're going to do this here. So now, the digital root of the digit divided by 2. This is division here. We have this little division sign in the middle. This is division. 1 second, please. Sorry about that. My dog went in. Okay, so now what we're going to do is we're going to take the digital root of the digit divided by 2. So what we're going to do is we are going to essentially divide this digit that we have here by 2. So we're going to divide this by 2, and this is going to give us a 4. Note that we don't have to worry about the digital root of this. This is not going to be a case where we have to do the digital root. Next up, we're going to do the digital root of the digit plus the battery holder and port plate count. We've already determined that none of these are present, so this is going to be simply adding 0. Now 4 will be our next digit here. So let's do this on 4. And we just get blue. Note that it is possible to only get one color present, so that's going to be very important to note down. So we're then going to do blue, which is simply the digit divided by 2. That's going to give us a 2. We're already done with the stage here. Let's hit this on 2. And hopefully soon we should be done here. Maybe 1 or 2 more stages, I think. 3 and 2. And just like that is a solved module. So as you saw there, it will flash all 4 of the colors. I don't think that actually normally happens, but in this case, as you can see, that did indeed solve the module. And just like that, we're done. Let's take a look at one final example. As you can see, this module is very simple. The problem is that you really don't know how many stages this is going to go on for. I believe it generally is kind of the 5 area, because if you think about it, it was, let me think. So we got blue, blue, yellow, green, red, green, yellow. So that was, and then red, yellow. So that was 5 in this case. No, that was 6, excuse me. I'm actually going to check the log here while I load up a new example. It was 4 stages, okay. Green, yellow, green, red, blue. Yeah, okay. So yeah, it's about, that last one was about 4. Oh, that was from previous examples, that's why. Okay. Alright, so let's determine our initial time first. We need to get that thing going. So we're going to do this by some of the digits in the serial number. So let's do this right here. 7 plus 7 plus 3. 7 plus 7 plus 3. Remember, we multiply this by 2. Then we do the digital root. So we've got 3 plus 4 is going to be a 7. 7 for this one. Let's see what our colors are for this one. And taking a look at our edge work, this is going to be a bit different, definitely. And we can already predetermine these values here for green and yellow, because these are the only ones that have to apply here. So green is going to equal what? And yellow is going to equal what? So indicator and battery count. In this case, indicators are 2. Battery count is 1. So in this example, this is the indicators are the greater of the 2. So this means that green is going to be 2 here. Then we have the battery holder and port plate count. 1 is greater than 0, so yellow is going to be 1. So there's actually going to be a value to yellow. So these are going to be the values that will add to the digit here for each of the green and yellow cases. And with the red and blue, we'll just simply add, we'll simply multiply or divide. So, and I believe the only way that blue actually pops up is if it's guaranteed to be an even number. I believe that the code actually does account for that. So it should result in an even digit. There should not be any rounding cases because it doesn't state this in additional information as far as I'm aware. So let's get right into this. So we're going to do this last digit being a 7. 9, 8, 7. Just a solid green. Okay. So just green is going to be the digital root of the digit plus the value that we got from here, which is going to be 2. We're going to get 9 from this, and that's going to be our digit here. So let's flip it on a 9. And as you can see, this module can be done very, very quickly here. 9. We have a solid yellow. Yellow, we're just simply going to be adding the 1 here, but this does give us a 10, because 9 plus 1 is going to give us a 10. We need to do the digital root here, which is going to give us a 1. Okay, let's hit this again. And as you can see, it's just building off of each other. Green, red for this one, so red, green. So we're going to be doing red, green here. So the digital root of the digit times 2, that's going to be just 2 right here. And then we're going to be adding on from green, we're going to be adding on 2. That's going to give us a 4. Flip it when it's a 4. Just a solid yellow. Is going to be adding 1, so it's going to be a 5. 6, 5. Oh, okay. And just like that is a solved module. So that actually was 4 stages, I believe, once again. So this is kind of just the whole idea of it. I wish it kind of did state in the manual what the range was of these stages. But overall, a very simple module to do. Just be very careful with the highlights, especially that light switch, because that is a very, very small highlight. It's probably the one thing. That's probably the one request if Goofy ever does watch this video, to perhaps make this the light switch a little bit bigger, especially on bigger bombs, because it's going to be very difficult to get back. It's very difficult to like find the correct spot for the switch, especially if it's far away from the timer. But as always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.